let me welcome you again. Hi, my name is Dennis. Welcome to Symfony UserGroup Berlin, the second talk. This time it's about the new Symfony Runtime Component that was introduced in Symfony 5.3, or will be introduced in Symfony 5.3 to be more precise. And this is just the first look, so I won't do any performance comparisons with different runtimes and stuff like that. It's basically to give you an idea of what the component does, why it might be useful to you. I think there are a few very interesting use cases that I hope will get more traction by having the runtime component in Symfony and making it easier to run Symfony in those different environments. And even if you are not interested in that, there are other reasons why this is actually a nice change in Symfony. So my name is Denis Brumann. I work at QOSSMIC and I have the title of Solutions Architect. And that basically means that I code, and from time to time, I also draw nice diagrams with Draw.io and write Confluence stuff for people that basically want to know what we did in the code, but without looking at the code. So yeah, it's basically architecture diagrams and things like that. And I mostly do it in legacy projects, but I like to keep up to date with Symfony, just to see some new code as well. And yeah, that's why I also always look at the newly introduced components, like the new runtime component. One note on experimental features in Symfony. We heard the term before in the first talk. Just to give you an idea what experimental means in terms of Symfony features, it doesn't mean that the feature is unfinished and basically you can expect if you run it that you will have bugs or anything. Obviously that still can happen, but experimental first and foremost means that the API of that feature is not stable. So it means that certain methods can be renamed, classes can be changed around a little bit. And especially if you extend things, for example, you have your own runner that you want to introduce, then you might experience changes in the next release. But the good thing is that those experimental releases are usually only experimental at the very latest until the next LTS release, because the LTS release will stick around for quite a while. There will be a new major version coming out. And so that means that all features should be as stable as possible and should not change, because if you change something in 6.1, then you will still have to maintain the old version in 5.4. And that's why experimental features usually will be unexperimental in the last version. And so you can expect not too many changes over time until 5.4. And especially if you just use it as a consumer, basically, you don't have to worry about that anyway. But yeah, just be aware that things can change around a little bit. And with that, let's start with what actually is a runtime. So in terms of PHP, you probably know Apache as an HTTP server that serves your PHP code, and maybe you also heard of Nginx. Those are probably the two most popular environments to run PHP in. And that is basically the level of environment that we are talking about. So you could make it even smaller. You can say your environment is just the PHP process you're running it. And you could even say that your environment is bigger or your runtime is bigger because you maybe have some load balancers and some other infrastructure stuff that you also consider part of the runtime. But the runtime component is basically roughly the layer above PHP process that runs Symfony, or actually the process itself, depending on the runtime. And that it was what is considered a runtime for this component. And why is that important? Because if you look at how Nginx and Apache works, you will notice that those things talk to PHP in different ways. And you might have stumbled upon this when you configure, for example, Apache that in a way where you don't use mod PHP, but instead use fast CGI. And of course, if you configure Nginx, you will notice that the hooking PHP into Nginx looks a little bit different. So for Apache, usually you have this load module thing where you load the PHP module. And for Nginx, you have this configuration where you have a fast CGI pass, and that either goes to this URL thing, the PHP FPM on port 9000, or some Linux socket thing. And so the way those web servers communicate with PHP is slightly different in terms of what they do. This also affects a little bit how PHP runs. So for example, with Apache, when you use a module, then Apache is responsible that when a request comes in, it will spawn a new worker for that request and then run Apache and PHP in this one worker for you for each request. Whereas with Nginx, you basically have your Nginx process that defers to the PHP FPM, and that PHP FPM is responsible for spawning a new worker for each request. And so there's a slight variation there. And for the most part, for you as a developer, you don't really have to care about this if you use those conventional web servers. The one thing where you might stumble upon differences between those is the kernel terminate event. Because if you look at that red box on the bottom, you can see that the kernel terminate event works as is expected only when you use fast CGI. So Nginx by default and Apache with load module, the terminate event will not run after your response is sent out to the user, and basically you get a fast response when you do some heavy loading. Instead, the process will still wait until the terminate event is finished and then send out your response. So in Apache, if you want to use the terminate event how it's intended to be used, you have to use fast CGI as well. So you can see the environment you run in can have an impact. Most of the time it shouldn't. And the good thing is that in terms of how you run Symfony, how you have to configure Symfony, you will not see major differences. But in fact, there are other runtimes. So for example, if you run the console command of Symfony, then it again runs into a different environment. This time it's PHP's CLI process and not PHP as a node in for example, PHP FPM sub-process or as part of the Apache module. And this time, the different environment actually changes how you set up your console command versus how you have the front controller in your web application. And you can easily see that when you look at the index PHP versus the console command. So you can see that there are a few things that look quite similar. For example, you have the .env file, then you do some debug stuff, and at the very end, you have the kernel that is being created from those environment variables. And the major difference is that because you're in a console environment, you don't have an HTTP request. So you have to load your arguments with argv input. And if you're on a server process, then you will have to get the request information that you got from your web server. So for example, Nginx or Apache. And those are in your global variables in PHP, and you have to create your request object from that. And then the kernel has to handle the request. You have to send the response, which basically sends some information back to the web server instance, so Apache Nginx again, and then those will send out the response. And then there's the terminate event that we talked about. And as I said, for the console application, there's a little difference because you don't really have a request and response. You have the arguments and options that you added to your console command that you have to read out from this long string, basically. And also you have your kernel, but your kernel will not send request or response. So yeah, you can see we have two different environments. At the core, they have the same thing. They have the Symfony kernel, but they interact with the kernel differently, and they require different kind of setups. And what's interesting also in terms of the runtime component is that for the console command, you basically have to get the request stuff, or the stuff that you would usually get from the request before you run something. And with the response, with the web server context, the original setup, the kernel is basically the same, but you do something not before you run the application, but afterwards. So you get the response back, you send the response, you call the kernel terminate event. So it's not as simple as saying, oh, all the stuff that comes before my kernel runs, I can abstract that away. You have to see that the input might be different in terms of you have a kernel handle with request and an application run with input. And also you might have to do things after you run the application as well. So it's a tricky spot to optimize for different environments, which luckily for our web servers, we did not have to do in the past. All right, so as I already mentioned, for different environments, other runtimes than Nginx and Apache, that's quite interesting. But since we pretty much all use Nginx and Apache, it's not that interesting. And why would I care about the runtime component if I want to stick with Nginx, for example? And one reason is that this index.php file might change, and it actually has changed over time. You can here see the index.php, the original recipe for Symfony 3.3. And you can see that it already looks a little bit different. You can see the trusted proxies and trusted hosts configuration here that you did not see with the most recent Symfony 5.2 configuration that I showed before. And if you then go from 3.3 to 4.4, you will probably not notice a change, at least I don't, but there is something in there. I just have to figure out where it is. Or is it still the same reference? Oh, I can't see it. Oh, I see it. So it's debug has changed to error handler debug, because with Symfony 4.4, the new error handler component was introduced. And so now you had to do this small change to your index.php to not get the deprecation warning and to not have an issue if you use Symfony 5, for example, where the debug component was removed. And since the index.php is in your public directory, in your code, you had to do this change manually yourself, or you would run into problems. And we could also do the same for Symfony 5.1, where there was another change. And again, I have to look up what this change was. I can't see it on the spot. It's the .env thing that was introduced. So it's this line now, and here the .env use statement. And yeah, in 5.2, there was another change. This time it's the trusted proxies, and you get the idea. So with basically in Symfony 5, every other minor release changed how the index.php looked. Luckily, because of the backwards compatibility, if you didn't do the change yourself, you would get deprecation warnings and would just be informed that, oh, in the future you will have to change that. But yeah, if you really want to keep up to date and you update your framework bundle and possibly other bundles as well, you would have to update the recipes to see what has changed. And then, especially if you made your own adjustments in index.php, you would then have to basically make sure that you merge the changes from Symfony back into your index.php, which can be quite annoying most of the time because people just wouldn't update their index.php. So that's where I wanted to be. But yeah, one of the reasons runtime component is interesting is that your index.php will now look like this. And it will just return a callable, and in that kernel you have the return new kernel. And as we saw before in the index.php and in the bin console, this is at the heart of your Symfony application. You need a kernel, and it gets some context information the environment variables, and then you do something with that kernel. Either it will handle your request and response, or you will wrap a Symfony application around that, or spawn a new application around that and run that console application. But the good thing is you don't have to worry about this anymore, because you now have this, and all the other configuration changes that you would usually get via a recipe, you will now get automatically by updating the runtime component, getting a new runtime and a new runner, and then basically the configuration has changed for you without you having to worry about it. Let's look how this looks for the console. You can see it's pretty similar. The only difference is that you have this if condition here. I don't know why it's in there and not in the index PHP. It might have been updated to be in both of them. But as you can see, the general idea is the same. You have the require once for the autoload runtime, then you have the kernel. And in this case, the kernel is also in a console application. And this is the interesting bit about runtime. Basically, you can return different things inside that callable, and Symfony will try to make a running Symfony application from this. In this case, this is how the Symfony runtime decides if you're running a web runtime, so for example Nginx Apache, or if you're running on a console application, so you have the Symfony console application. And you could also just return a single command, and Symfony would create a single command application for you, which is quite neat. But let's look at the runtime component itself and what it does with this new index PHP and console PHP. So the documentation, I think, says that the runtime component decouples the bootstrapping logic, so your index PHP and your bin console, from any global state to make sure the application can run with runtimes like PHP FPM, React PHP, Swool, and others without you having to make any changes to the bootstrapping logic yourself. And especially if we come to React PHP and Swool, you will see why this might be interesting. And this is what we already saw. We have the index PHP. Let's go into a little bit detail how the runtime component works. So first of all, you will see the autoload runtime PHP. This is one thing that runtime component does. It acts as a composer plugin that will basically, once you install it, create an additional autoload file inside the vendor directory called the autoload runtime PHP. And this is basically the code that will handle the callable that you return in line 7 here. And this is what the autoload runtime PHP looks like. You don't really have to care about it. As I said, it's generated for you and you don't really have to touch it. And this is one place where the runtime component can introduce updates by basically giving you a new autoload runtime PHP where they add, for example, a few lines of code, and whenever you run composer update or composer install, it will basically check if this autoload runtime PHP is still accurate. But hopefully it's not the file that will change most often. And you can see that it doesn't look anything like our old index PHP. So we have some new environment variables for the runtime, which basically will tell the runtime which runtime to use later on. By default, it will be the Symfony runtime. And you can also specify runtime options. We will get into that a little bit later. So basically, you can specify additional information for your runtime if it needs it. So for example, if you run React PHP, then you will basically run a web server in a PHP process. This web server has to listen to a specific port, and then you can configure this port in those runtime options. And this is the configuration stuff. This is how the options look. I'm not quite sure if this is still accurate. It might be that the options key is removed. So you can either use an environment variable, or you can also specify those runtime options in your composer JSON under extra runtime. most of the time, I think you would not want to do that. You want to use the environment variable, but yeah, in case you want to make sure that everyone on your team is basically using the same runtime and has the options set up as you wanted, then you could specify it in the composer JSON as well. But yeah, probably not your first choice, but you can already see what kind of options there are. For example, you can have debug and the application environment, in this case dev, configured as runtime options. And sorry, the runtime itself has this interface. So basically what will extract your runtime, your callable, and then run that callable, that is your runtime. And it has two steps: the get resolver, which basically gets your callable and then gives you back the resolver for that callable. Basically what this does is it makes sure that when your callable returns something or requires if your callable requires some options, that those options are set, and it will make sure that it can be resolved into something meaningful for your runner. And then the next step is to get the runner from the runtime itself. So you pass it the application object, which is basically what you get back from your resolver once it called resolve. And as I said, the resolve phase takes into account your callable and basically runs that. And then I'm not even sure if it runs the callable at that stage or the later stage, but yeah, you get something runnable back, and then on the runner you can run to actually start your application. So this is basically where your kernel handle or your application console application run would be called. And this is how it looks in the autoload runtime PHP. So you have the runtime, and you call the get resolver. App is your callable that you got in your index PHP, and then you get call resolve, and what you get back is another app. So again, this is basically the callable and the arguments that your app requires when it will be run. So basically the resolver will extract all the meaningful configuration options that you need to pass to the callable. We saw that, for example, we have this context array with append and with the debug information. So that is what is extracted during the resolve phase. Then we will call our callable and pass it all the arguments that we extracted during resolve. And what we get back is an application. So in terms of the index PHP, you get back a Symfony kernel. And in terms of the console, you get back a console application from this callable. And then this application will be passed to the runner, which runs this. So in terms of the index PHP, again, if you have the kernel, you will have to do the kernel handle, you have to send response, all this stuff. This is basically what's done in run. And I know it's super abstract and difficult to get into. And what you can use as a kind of help is the resolver stage is basically everything that happened before you have your new kernel in the current index PHP, and the runtime run is basically everything that happens after you have this kernel, or in terms of a console application, the application object. So it's basically the before and the after stage of your bootstrap thing. And yeah, so here you can see the once you call the callable, you would get this kernel object back, and that would basically then handle the request. So this is what the Symfony runtime looks like, specifically the getting the runner for an application. And this is where you can already see that you can pass in a lot of things, or you can return a lot of things in your callable. So we already saw it can be a kernel interface, so your standard Symfony kernel. We also saw that it can be a Symfony console application. And as I mentioned, it can return a command. And in that case, the runner itself, or the get runner from the Symfony runtime will basically know, oh, if I have a command, then I need to run this command inside a console application. So it sets everything up and then goes back to get runner to basically pass it instead of the command, the now generated single command application. You can also just return a response in your callable. So basically, if you want a super fast Symfony application that doesn't need a kernel or anything, you just want a request and you like to work with the response object from Symfony for some reason, then you can basically just have your response, render it out to the user, and you basically just have the object kind of abstraction around echoing a response. There's a few more ways that the callable can be used, and those are not handled by the Symfony runtime, but instead by the generic runtime. So the generic runtime is basically any PHP thing that is not Symfony specific, and in there your callable can, I think it can just echo, so it doesn't return anything, it just echoes, and that is then basically returned. And there might be a few other things. So if you ever want to use runtime outside of Symfony, you would, for example, extend the generic runtime, much like the Symfony runtime does, and then you would check in your runtime if the object returned from the callable is of a certain type. So for example, if you want to rather use the PSR request and response objects, then you can just check for this PSR request response stuff, and then you can handle that yourself in your runtime. Luckily, I know that this is a lot and super hard to understand, like why do I need this? What do I need to care about? All you have to care about is that your index PHP and your console is now a lot smaller, and it will not change as often between minor releases. So you don't have to care about updating the recipes as much as you had before. And the other thing that is important to you is you don't really have to write your own runtimes. Most of the time, you will just use the Symfony runtime, and hopefully other projects, if you want to run Symfony in different environment, will provide their runtimes for you, so you don't have to do the work yourself. Because basically, if you want to run a Symfony run application in React PHP, for example, it will be pretty much the same for everyone. So there just needs to be one runtime that everyone can use, and you don't have to write your own. And how does that look? First of all, let's go a little bit into custom runtimes. I already mentioned React PHP. I mentioned Swirl. Roadrunner is another alternative runtime to Nginx and Apache that is out there. And I think one of the most well-known is Amazon Lambda. They basically all have in common that you have one PHP process that is long running and now handles multiple requests. And the benefit is that because you booted your PHP process once, you had all the autoload stuff and everything, when the second request hits, then you don't have the penalty of spawning another PHP process, getting everything up again. And so theoretically, your request handling is a lot of faster than it would be where for each request you spawn a new process. The downside is everything runs in the same PHP process, so you have to be really careful that, for example, your services are not stateful, because that state might carry over into a second request. And luckily, Symfony had a lot of improvements there. It's out of scope for now. Let's look at why those runtimes are now easier to use with the Symfony runtime component. And for that, let's look at how you would normally, for example, get Symfony running in a Swool application, or more precisely, get any Swool application running that is not even Symfony specific. So you have a Swool server, as I already mentioned. You usually have, because the PHP process now manages multiple requests, it basically has to act as a server that receives requests, sends out responses, and then keeps running to receive the next request. And then on certain events, you would basically then, when the server starts, you could react on it by having a callable that does something. In this case, it echoes just that, oh yeah, I started your Swool server. The more interesting thing is this thing. Whenever this server receives a request, it will then create a request and response object for you, and you can then handle those request response objects. And you have to be careful, those are Swool requests and responses, so they are not Symfony requests and responses. And then you run server start, and basically this thing would run and run and run until you either have some segfault or other error that stops the process, or you just stop it yourself. So this is how would Swool as a runtime would work. And basically inside this block, you would now have to create a Symfony request from this Swool request. You would have to boot the kernel. Then the response returned from the kernel would need to be passed as a, it had to be transformed into a Swool response. And this would all need to happen inside your index PHP. And if you write all the stuff in the index PHP, then obviously it will not work with Apache or Nginx again. So you might be tempted to have something like Symfony used to have with the app PHP and app dev PHP, where you have a new front controller for this environment just so you can test out how your application runs in Swool. And with Symfony Runtime, you don't have to do that, because all this stuff is abstracted away into a runtime, and your index PHP will still be the same as it was before. You have the kernel, so you have the callable, and that callable will return a kernel. And then a custom Swool runtime would pick up this kernel object and will do all the conversion from Swool request to Symfony request, and the response as well. And yeah, so for Roadrunner, it's a similar thing, but you can see it looks different even than Swool, even though it kind of does similar things. In this case, you have a worker, and this worker now will always wait for requests and will run in a loop, much like basically this server will just run in an endless loop. Again, you have different request and response objects. This time it's from the PSR standard, so PSR 7 request and response. And again, in your index PHP, you would have to adjust your code to make it run for Roadrunner. And React PHP is the same thing again, but different. You now have a React HTTP server that kind of looks like what we had with Swool. You have a second socket server that listens to something, and so this server is basically what's handling your request. In this case, again, like with Roadrunner, it's a PSR request, and you also return a PSR response, I think, as React HTTP response. And then you have a loop run, which looks a lot like we had with Swool. So all those different runtimes do similar things, but obviously they have their own servers. They have request and response differently, for example. And so if you want to switch between those environments, you would always need to adjust your index PHP. And all the time it would be incompatible with, for example, if you had your React PHP index PHP, it would not work with Swool, and it would not work with Apache or Nginx anymore, which basically means that if you want to play around with these alternative PHP runtimes, it's a lot of work. And now what you get with the runtime component, as I mentioned, you would have your custom runtimes. For example, for React PHP, where you have your runner that looks for this request handler now instead of a kernel, or it can be a kernel, and that will be transformed into a request handler. And then you have the runner itself, which has all the logic that you saw in the original React PHP documentation code, where you now only have to make sure that you, for example, transform all the stuff so that the React PHP server that uses PSR7 will work with the Symfony kernel. So in those cases, you will have to adjust the kernel as well. But as I mentioned, you don't really have to care about that. There are alternative runtimes readily available. There's this PHP runtime project started by Tobias Nyholm, and he already provides a few runtimes for you. So let me switch my screen to give you a look. So this is the repository. And just to give you a feel how those different runtimes look, let's maybe quickly look at the Roadrunner runtime. And basically what you see here, that the index PHP looks just like we saw in the slides. It's a default Symfony index PHP. The only difference is that now via environment variable or composer JSON, you specify that you don't want to use the Symfony runtime to run this. Instead, you want to use this Roadrunner runtime. And this is then what it looks like. So the runtime itself will receive the Symfony kernel, wrap it in a so-called new runner that is basically the Roadrunner runner. And this runner is then responsible for doing all the Roadrunner specific stuff, which means it will do the PSR changes to have the transform the Symfony request into a PSR request, Symfony response, PSR response, and it will do some other changes. I haven't looked at that much. This is basically what you saw in the Roadrunner documentation. You have to create a worker. It's a PSR7 worker. It will now use those factories that we have here. And then inside this worker, we use our Symfony kernel for the handle, and we have the Symfony request and the Symfony response, and your worker will then respond with the PSR response, and you can still call kernel term. So basically, it's everything that you would write in the index PHP, you now have in the run method, and you don't have to care about this anymore. The same for all the other runtimes. So if you, for example, want to use Swool, if you want to use React PHP, or if you want to run in AWS Lambda, you have the Breath runtime. You don't have to change your code, and you can quickly switch between environments, or even deploy a project to multiple environments with the same code basically running, and then compare between them. And this is especially interesting if you want to use those alternative runtimes. But as I mentioned, even if you don't want to use them, the benefit is that you don't have to worry about all those changes to the index PHP. And yeah, basically what this does, it paves the way for Symfony to be more easily used in asynchronous PHP environments like Swool, like Runtime. And I already ran a lot of time, so I will just stop it there and ask questions if you have any.